Hello and welcome to topic 6 of the physics unit for science 30, visible light. Visible light is what we can see, and it is only a small portion of the electromagnetic radiation spectrum. What colors have the highest frequency and shortest wavelength? Blue and purple do. What colors have the lowest frequency? So here's the highest frequency and shortest wavelength is blue and purple. Lowest frequency and longest wavelength is red. Who is Roy G. Biv? It is a acronym to remember the visible light spectrum. So Roy, red, orange, yellow, G, green, and Biv, blue, indigo, violet. The source. Light is emitted by objects that are hot. For example, a light bulb, a fire, and a sun all emit light, visible light. Light travels in photons. Photons are packets of energy. Light has both wave and photon characteristics. The color of an object is not contained within the object. The color is the result of light which strikes the object and is then reflected by it. A typical wave. Here we've talked about this before. Amplitude is how high the wavelength or the wave is. Wavelength is from crest to crest or from trough to trough. Propagation means that this wave continues. When light hits an object, the incident wave splits into a transmitted wavelength and a transmitted wave and a reflected wave. Types of electromagnetic waves. Recall we've talked about radio waves, microwaves, infrared waves, visible light waves, and ultraviolet waves. Excuse me, all have different wavelengths. So visible light is measured in nanometers or 10 to the minus 9 meters or 10 to the minus 3 micrometers. So it's very small. Review questions. Which color has the longest wavelength? Which color has the highest frequency? Which color has the highest energy? So if we look at our chart over there, frequency increases as you move in this direction and wavelength increases as you move in this direction. So violet has the longest or the highest frequency, and it's the shortest wave. Red has the shortest wave, or the longest wave, shortest wave, lowest frequency, highest frequency. What color has the highest energy? Violet. We see the reflected light off of objects. Reflected light is what bounces off. So light from a barcode scanner bounces off. This is how the barcode scanner reads light. A mirror is a perfect reflector, and perfect is in quotation marks because nothing is perfect. The light hits the mirror at an angle and then is reflected off at an equal but opposite angle. The law of reflection says that the angle at which light hits is reflected equally but oppositely. The manipulated variable, when we're talking about an experiment, remember the manipulated variable is equal to the responding variable. The angle of incidence is equal to the angle of reflection. So the angle that it hits is the angle of incidence, and then the angle of reflection is the angle that comes off. Reflected light. The incident light hits at an angle. the reflected light, it comes off at the same angle. This is measured from the normal, or 90 degrees. Normal is perpendicular to the mirror. So here is the incident, here is the reflection, and normal is 90 degrees, or perpendicular to the mirror. The angle of incident therefore equals the angle of reflection when you measure from that perpendicular imaginary line, or normal. Here's an example. Again, angle of incidence, angle of reflection. Angle of incidence, angle of reflection. Those angles are the same. Technology that uses reflection. One is a reflecting telescope. Light is collected by a parabolic mirror and reflected into a focus. A parabolic reflecting satellite dishes. So you've all seen satellite dishes. They can be big or small. The older ones were bigger. The smaller ones are newer. Receive weak radio waves from satellites and focus it in the middle. So here you have a reflecting telescope. So light comes in, bounces off the mirror onto a secondary mirror, which causes the light to be focused in your eye so you can see distant objects clearly. If a wave source is placed at the focus of a parabolic surface, the reflected rays are parallel. So if the source is here, and then light bounces off, what you will see is the waves coming off in a parallel orientation. If the light comes in from outside the parabolic surface, and then they outside this, and then they encounter this parabola, which is sort of a bowl shaped, they become focused as they reflect off the surface so that these reflections converge. Excuse me. Light rays reflect and refract. Refracted light. Like dipping your finger in a glass of water, electromagnetic radiation waves bend as they go from one medium to another, and this bending indicates that these waves change speed. This bending is refraction, right? So that's the definition of refraction, bending of light. So here you have an incident ray coming through, and this is in air, and then you have a refracted ray. As it enters the water, the angle changes slightly. So the light bends. So light rays refract or bend. They cause pools of water to appear more shallow than they are. So the formula is sine theta 1 divided by sine theta 2 is equal to n, where this is the angle, the sine of the angle of incidence, and the sine of the angle of refraction, and n is the refractive index. Each material has its own refractive index: air, water, oil, plastic, glass. Light rays bend towards normal when going from low to high N. So air has a lower refractive index than water. So this light ray will bend closer to this perpendicular line, closer to normal. So air is less than water, it'll move towards 90 degrees. So the incident ray was 40. If it moves towards 90, this number gets smaller. This is 29 degrees. Light going from low N to high N refracts towards normal. Light going from high to low refracts away from normal. So as it goes from air to water, we have 45 degrees as your angle of incidence, 32 degrees is your angle of refraction. it's going towards normal. Here, air and glass, again, low to high, 45 to 28, and then air to diamond, 45 to 17. Diamond has the highest refractive index because it changes the angle of refraction more than any other substance here. So air is more than water, air is more than glass, air is less than water, air is less than glass, and air is less than diamond. Diamond refracts it more, so it has a higher refractive index than the rest of them. When light refracts, the speed, wavelength, and direction of light waves change. The frequency stays the same. The frequency does not depend on the medium, but the speed, wavelength, and direction do depend on the medium. What is this showing? So here you have when light travels from low N to high N, the light ray bends towards normal. So this angle is getting smaller. When it goes from high to low, it goes away from normal, so this angle is getting bigger, and so this angle should equal this angle. Each color refracts light differently. Each color has a different frequency. So white is a combination of all the colors: red, orange, yellow, green, blue, indigo, and violet. Violet has the highest frequency, red has the lowest frequency, so high frequency, low frequency. White light contains all of the colors of the rainbow. When white light enters a prism, it spreads apart because red or all of these colors of light refract slightly differently through this glass. So here we have high frequency light at the bottom and low frequency light at the top.